uniform circular motion. Uniform circular motion occurs when an object goes around in a circle and when the speed never changes. If the speed doesn't change, then the velocity, of course, does change because the direction changes all the time. But the speed does not. So here we have our circle. Let this be radius r. And at this moment in time, the object is here, has a certain velocity. This is 90 degrees. And at later in time, the object is here. The speed is the same, but the direction has changed, 90 degrees. So these vectors should have the same length. In a situation like this, that we have uniform circular motion, so it's uniform, circular motion, we first identify what we call the period, t, in seconds. That's the time to go around. Then we identify what we call the frequency. That is how many times it goes around per second. I prefer the letter f, but our book uses the Greek letter nu. I find the nu often very confusing with the v of velocity, and that's why I prefer the f. It is 1 over t, and so the units are second minus 1, but most physicists would call that hertz. 10 hertz means to go 10 times around per second. And then we identify omega, the angular velocity, omega, which is in radians per second. Since it takes t seconds to go around 2 pi radians, omega is 2 pi divided by t. Now then we have the speed, which we can also think of as a linear velocity. How many meters per second is linear as opposed to how many radians per second, which is angular velocity. So this is a linear velocity, this is an angular velocity. And that linear velocity, which in this case is really a speed, is of course the circumference of the circle divided by how many seconds it takes to go around. And that is also omega r. And that is now in meters per second. All this is only possible if there is an acceleration. And the acceleration is called the centripetal acceleration. It is always pointed towards the center, A centripetal, A centripetal. And the centripetal acceleration, the magnitude, is v squared divided by r, which is therefore also omega square r, and that of course is in meters per second squared.